Additive manufacturing is a manufacturing technique that uses layering material to build a part. DoD receives funding through Congress for research and development. We try to select parts for additive manufacturing today based on certain attributes. Is it an obsolete part? Is it a part that has a long lead time? Does it cost a lot? Can we improve the design on that part?
In traditional manufacturing, the cost per part that you're making exponentially decays. If you're only going to make one, it's very expensive because all the money and time doesn't necessarily go into coming up with the part, but it goes into setting up a production line to be able to manufacture the part, be able to QC the part. And so that's why in order for most traditional manufacturing to turn a profit, you need to produce tens of thousands to hundreds of thousands of parts.
The interest of DLA in additive manufacturing, partnering with the military services, is because in the life cycle of a part, DLA is in sustainment phase. So if the military services start producing additive manufacturing parts on their side, we have to balance what military services are bringing into the supply chain and what DLA already has in the supply chain in terms of stocks on hand or stocks that are in long-term contracts that are coming into the sustainment phase.
The Defense Logistics Agency and the Marine Corps partnered to try to find an additive manufacturing solution for an M1 Abrams tank impeller.
In a desert environment, it's very important due to the sand and dust that gets kicked up as the vehicles are moving. And if the air filters become clogged, the vehicle will have to stop and blow the filters out to remove the dust. And then that way they continue on with the mission. With the impeller, it allows the crew to maneuver further without having to service the air filters.
This was pretty groundbreaking because even though the Marine Corps is moving away from tanks as a capability, the part itself and the technical problems we had to solve in order to certify it, that will transfer laterally to other platforms.
Our partners in additive manufacturing are the military services and industry.
With the advent of additive manufacturing, we've been asked by the Defense Logistics Agency and the United States Marine Corps to turn our talents toward introducing additive manufacturing into the Marine Corps.
We are literally testing samples to failure. So we're measuring the strength of materials, we're measuring how much ductility the materials have, and making sure that the materials will survive use.
So additive manufacturing has the ability to transform the supply chain not only for the United States Marine Corps, but for the DoD in general. It offers a supply alternative for either obsolete or long lead time items that are prevalent in systems and platforms in the Marine Corps and again throughout the DoD.
The benefit of additive manufacturing is going to be allow us to push further with the mission, whether it be time or distance, and not be waiting on an item to repair the vehicle.
We're not trying to reinvent the supply chain from the ground up, we're trying to supplement it. The end goal for this is increased Marine Corps readiness, having a shorter, more responsive supply chain, and a greater ability to sustain and support ourselves logistically in an expeditionary environment.